This lecture will discuss about the design process in control systems. Normally, the easiest way without guarantee that we can design the systems with trial and error. Okay, it is one of the well-known methods of problem solving. Sometimes we call it educated guess. You can, based on some fundamentals we design, but then there is no data or analysis that prove our design is improve or better. All right. Now we want to see what is a step. I think we have discussed this earlier, but I'll go through again. So there are a total of 6 steps. First one is transform requirement into a physical systems, meaning that we have to understand the system that we're going to design. For example, we need to understand what is the input requirement, what is the output requirements, what is the accuracies, what is the response, and so on. And then we can draw functional block diagrams that you did before in the first assignment. Step 3, create schematics. Step 4, develop a math model. Okay, this is important. Step 4 is very important because without step 4 we can't actually jump to step 5 and step 6. Okay, step 4, in step 4 we have to sort of develop or create an equivalent mathematical math model from physical model. Okay, normally any system is a physical model in the real world. So what we have to do, if it is a mechanical system, we have to use the theorems, the mechanical system theorems such as Newton laws, gravity laws, and so on. So for electrical systems, we can use Ohm's law, Kirchhoff laws, and so on. For mechatronics, we can combine those two. All right. Okay, from this theorem, we could produce a math model based on at least these 3 types. There are some other types, but we need to focus on these 3 types in this course. The first one is differential equation, which is a time domain representations of the systems. State space also in time domain, and transfer function in frequency domain. So they are basically interchangeable. We could choose any model that we think that is easy to represent. Then we can interchange, and then we can transform back to the original model. All right, that's what we're going to do now here. Okay, the step 6, analyze and design. So in analyze and design, we have to understand what is the input requirements. For this case, we have 5 inputs. There are impulse, steps, ramp, parabolics, parabola, and sinusoid. Okay, later we'll do this. We'll discuss this in detail. All right, this is the output response of the systems that we need to analyze based on the model that we created. So we are interested to see that what is the output response of the systems that we designed. From that response, we could determine the performance parameters such as time constants, rise time. The rise time, how fast the response reach its final states, what sort of overshoot that the system will generate, settling time and damping ratios and so on. Okay, so basically we are focusing on this plot diagram here, plant here. So whatever physical system that we have, we have to convert or transform them into a math model so that we can do a further analysis of this, and then we could then design a closed loop controller so that we can control the output, the response of the output. Okay, from now on, please remember these block diagrams because it's very handy for control system. So basically plants, the plant is considered in control system is considered a black box that we have to understand before we could design a control system. Okay, so now after this we will discuss about how to model the plants. All right, thank you very much.